Okay, so talking about exam one, uh, the median score in the class, so like you take the lowest half of the scores, put it over here, the highest half of the scores over here. There's one person in the middle, and that person is the median score. And the median score was about 86%. And so that's pretty good. I mean, really good. Uh, Overall, the test went well, but I want to talk about um, something here that I mentioned this at the beginning of the semester. Um, this class, whether I teach it or whether anyone else teaches it, um, of the people who register for this class at the beginning, regularly 30 to 40% of those people end up with D's or F's or W's. Okay, so that's a really big fraction, and you know I would love to have that be zero. Um, and so I kind of so I want to talk about how you should look at this exam score. Um, about a quarter of the class is over now. Um, and this is the first chance to get a really good sense of overall where you stand. It doesn't say everything about where you stand. And like, I know, I already hear some people saying like they misunderstood a question or whatever. It doesn't tell you everything, but it's the first best bit of information about how well this class is going. Okay. So I want to say two things. The first one is points wise, this doesn't cause any problems, even if you got a zero on this, which, nobody got a zero. But if you got a zero on this, points wise, you're still perfectly fine. So you don't have any problem with points yet. Um, if you got a zero on this test, whatever grade you get on the final can count as the final, and it can replace the low score you got on exam one. Okay, so nobody has to count this score as part of their grade at all. Okay. But the second thing is this test is the best predictor we have of how well you're preparing for the way I'm designing this class. So this is the best predictor of how this class would go how it would continue to go if you kept doing what you're doing. And I would say, 20 is a pretty good cutoff for like being in the ballpark of like a C and above versus being really what I would say in danger of heading on a path towards getting a D or an F or whatever. Um, so if you got a score in the teens, I think you should take it as a strong indication that you really need to be, conscious, clear to yourself about how you want to approach this. And one way you could approach it, obviously, like nobody, you know, millions of people have dropped physics 1 and gone on to super successful careers and whatever else. But if you want to pass this class, do well in this class, you really are going to need to change something. Okay, if you keep doing what you're doing, it's going to keep going like that. So, and I have 5 office hours a week in the tutoring center. I have a total of about 80 students this semester, and I probably have a total of about 10 of those students who've come to office hours. And so I'm just always there, ready to help you understand stuff. And so I think what you should do, if you're committed to making this class work and the first exam didn't go as well as you want it to go, you should come to office hours with your binder and with your exam, and we should start to talk about what kind of things you've been doing. Maybe I can help you identify some things that you can change, help you identify some misunderstandings that you have. Okay, so that's all. Nobody is in danger of failing because of points, but there are people who need to be conscious about how they're going to get back on the right track before points start to be important. You know what I mean? Anybody have any questions about that? About how the exam went, or what it means, or office hours, or anything like that? I think so when I say bring your binder, one of the best ways, I think the most useful ways for me to understand what things you're approaching the way I'd like to see you approach them and what things you're not, is to look at the work you've done. And then I can sort of see, like, okay, up to here, everything looks good, but here you're making this assumption that I think is a misunderstanding, or, it's helpful. Okay, so those are the 2 things. So now let me go over some of the questions that I saw mistakes frequently. So the first one, number 1, it said that you had velocity as a function of time as negative 3t squared, and you're given that when time is equal to 0, the position is 3 meters. To get the acceleration as a function of time, you just take the derivative. Almost everybody did that right. But to get the position, so the position as a function of time is the integral of the velocity as a function of time with respect to time. And so that is negative t cubed plus some constant. And what I saw a lot of the time was people either didn't include that constant of integration, or they didn't solve for the constant of integration. They just left it like that. Once you have this, you can use the boundary condition. And it says that 3 is equal to negative 0 cubed plus c. And so that tells you that c is equal to 3. Okay. And then position as a function of time, the final answer is negative t cubed plus 3. And then for figuring out whether it's speeding up or slowing down, well, what 1 or 2 people did is plotted out the position versus time graph and thought about the slope and the concavity. That's an okay way to do it. You can also just plug in values for velocity and acceleration and see if there are any times that, is it always the same sign? Is it always opposite signs? In this case, they always had the same sign. They were negative for all positive times. And so that tells you that it's speeding up. And then the next one, number 3, that I took a lot of points off. So this one people might feel like is sort of unfair. I tried to clarify that I wanted you to do this. I didn't say anything on the test. I don't know. So if I did you wrong, I'm sorry, but I think the way it's scored is the way I'm going to score it on this one. But I wanted you to show something about the relative motion equation that you're using. So some people just sort of thought it through and even gave the right answer by thinking it through, but didn't show the relative motion equation. And I didn't take off all the points, but I took off points for people who did that. What I want to see is, so you can think of it as like the acceleration of the object relative to the ground, and it doesn't matter what subscripts you use to describe different things, is equal to the acceleration of the object relative to the elevator plus the acceleration of the elevator relative to the ground. And then depending on what you called your positive direction, these accelerations could have been positive or negative, but this object is in free fall, and that means it has free fall acceleration. It says that the elevator has a downward acceleration of 3 meters per second squared. So that would be negative 3 meters per second squared. And then this is the one that you're solving for. So then just do the algebra, and you get that the acceleration of the object relative to the elevator is negative 9.81 minus negative 3. And so you get negative 6.81 meters per second squared. So the video camera inside the elevator, to the video camera inside the elevator, it would look like this thing had a downward acceleration of 6.81 meters per second squared. And then the last one that a lot of people had problems with was number 5. So you started out with this vector with a magnitude of 15 that made an angle of 35 degrees with the horizontal. And you were given 2 coordinate systems. The first one had positive x this way, positive y this way. Draw the vector with its tail at the origin without changing the orientation. And so this angle is 35 degrees. And so the counterclockwise angle from the x-axis, positive x-axis, to the vector was 90 plus 35. And so this answer is 15 times cosine of 125, 15 times sine of 125. And then part B, the coordinate system was the exact opposite of that. So positive x is this way, positive y is this way. Again, you put the vector there without changing the orientation. The angle from the positive x-axis to this is either 305 or negative 55. And so the answer is 15 times cosine of 305 15 times sine of 305, and then just give that decimal answer for both of those. So the number one thing that people did wrong with that problem was as they rotated the coordinate system, they rotated the vector kind of along with it, and then got sort of confused, like the angle's the same in every one, you know. Yes? No. I think that's right. Any questions about any of those? Okay. So like I said, I think in almost every case, if you look at this and you say this did not go the way I want, even if what you got was a B or something, and you're like, that's not what I want. If you look at your score and it's not what you want for the semester, it means most likely you're going to have to change something about what you're doing, you know. And I'd be happy to help you change what you're doing. And I think just about everybody in this class could make this class work if you try to turn things around now, you know, the people it didn't go well for. So, but you just need to make that decision and you need to act on it, okay? All right, well, we have a quiz today in 10 minutes or something. Does anyone have any homework questions or anything that you'd like me to go over before the quiz? Do you have the problems with you, or anybody have the? Thanks. Okay, problem number 1 on particle kinematics. Okay. Okay, so we have this object, a pool ball that's rolling along the planar surface of a pool table, and it says that its initial velocity vector is 3, -1. So you can draw that as, so go 3 that way, go 1 in the -y direction, and that means that its initial velocity vector is this way. Okay. And this is with the coordinate system like this. Give an example now of an acceleration that would make this ball keep moving in the same direction and speed up. Well, based on the stuff we did in lab last week, to speed up, so an acceleration we always break up into 2 parts, a part that's parallel to the velocity vector and a part that's perpendicular to it. The part that's parallel is the one that determines whether it speeds up or slows down, okay? So the parallel part of this acceleration, does that have to be in the same direction as V0 or the opposite direction? Yeah, so for part B, to speed up, A parallel needs to be in the same direction as V0. Now it says this acceleration should keep it moving in the same direction. So in other words, no turning. So if there's no turning, A perpendicular has to be 0. Okay. So these two together mean that the acceleration has to be in the same direction as that velocity, what I called v0. Okay, so what are some possibilities, or what are the, if you wanted to come up with components, how would you get a vector that's in the same direction as v0? Yep.
Well, it would be 3, -1 times any positive.
That's exactly right. Yep. So the acceleration would be, you can think of this as some number c times 3, -1, where this c is any positive number. If that c was less than 1, but still positive, say it's 1/2, then the acceleration would be smaller, it would be 1.5, -0.5, but it would still be making it speed up. If c was bigger than 1, you'd get values of the components that are bigger than those, but it would still be in the same direction. So like if c was 2, this would be 6, -2. Okay. And then for part C, it asks what is an acceleration that would make it slow down in the same direction. So to slow down without turning. Well, that's similar. We still have to have this A parallel be the only part of the acceleration, otherwise it would turn. But this time we have to make it opposite v0. A perpendicular still has to be 0. And so here you could call this, acceleration is equal to c times 3, -1. But this time that c has to be a negative number, and it could be any negative number. And then for part D, it asks, give an example of an acceleration vector that would make the ball turn but remain the same speed. Well, this time, since the speed isn't changing, the parallel part is 0. The perpendicular part has to be something. It doesn't matter what this is, but it can't be 0. And so if you can come up with components that are perpendicular to those two, so let's see, we have a vector like this, that's v0. Say we wanted to come up with an acceleration vector like this. Well, the slope of the velocity is -1/3. And so the slope with something perpendicular, you can do this as just the negative reciprocal. So that's -1 over the slope of the velocity. so +3. Okay, so at that instant, that'll make this object turn but not change speeds. And then the question is E. Yes. Oh, so something with a slope of 3 would be, rise over run is 3, which is 3 over 1. So this vector could be like 1, 3. This is still D. And then, so this is all at an instant. And now it asks, well, if we kept up this acceleration, what would happen as time went by? Okay, well, if it started out with a velocity like this, and then it turned, its path would do something like that, okay? And if you kept applying that acceleration, so this is velocity, this is acceleration. Now this is velocity. When you keep the same acceleration, you can see that those aren't perpendicular anymore. Okay. So as time goes by, if you didn't change the acceleration and this thing turns, this thing would start to change speed. The way I have it drawn here, it would start to speed up, because to make this vector, you have to have a perpendicular part, but you also have to have a parallel part that's in the same direction as the velocity. Anybody have any questions about that? Any other homework questions you want to see right now? Okay.